is antimicrobial susceptibility testing. Measures the ability of an antibiotic or other antimicrobial agent to inhibit bacterial growth in vitro. Two methods of antimicrobial susceptibility. First, test tube method, a serial dilution method, tedious and time-consuming. It is used to determine the bacteriostatic and bactericidal concentration of antibiotics. Second, this diffusion method, the Kirby-Bauer test, to determine bacteriostatic only and routinely for laboratories. The importance of antimicrobial susceptibility testing is very important for treating infectious diseases and monitoring antimicrobial resistance in various pathogens. It is essential that the reports are relevant, timely, interpreted correctly to ensure quality control and etc.
For the interpretation of the antimicrobial susceptibility testing, for its goal, the goal of testing are to detect possible drug resistance in common pathogens and to assure susceptibility to drugs of choice for particular infections. The most widely used testing methods includes broad microdilution or rapid automated instrument methods that use commercially marketed materials and devices. Manual methods that provide flexibility and possible cost saving includes the disk diffusion and the gradient diffusion methods. Antibiotic, we're going to discuss first about the penicillin. And under this, we have the E. coli, wherein it is resistant because there is no zone of inhibition. Next is the Staphylococcus aureus, wherein it is a susceptible and there is a wide zone of inhibition. For the next antibiotic, we have the tetracycline. For the E. coli, it is a susceptible and there is a wide zone of inhibition. For the Staphylococcus aureus, it is also a susceptible and also there is a wide zone of inhibition. For the third antibiotic, we have the trimethoprim. For the E. coli, it is a susceptible and there is also a wide zone of inhibition. For the Staphylococcus aureus, it is also a susceptible and there is a wide zone of inhibition. For the fourth antibiotic, we have the erythromycin. For the E. coli, it is an intermediate susceptible and there is a minimal zone of inhibition. For the Staphylococcus aureus, it is a susceptible and there is a wide zone of inhibition. For the last antibiotic, we have the ampicillin. For the E. coli, it is an intermediate susceptible and there is a minimal zone of inhibition. For the Staphylococcus aureus, it is susceptible and there is a wide zone of inhibition.
Classification of antibiotics based on mechanism of action. So what is antibiotic? An antibiotics is an imprecisely applied term generally used to describe any compound, natural or synthetic, that inhibits the growth of or actively kills microorganisms. There are major fundamental properties of antibiotics, whether bacteriostatic or bactericidal. In bacteriostatic antibiotics, it inhibits bacteria from reproducing but doesn't otherwise kill them, while in bactericidal, it can actively kill bacteria. There are major one mechanism of antibiotics. Some interferes with the cell wall synthesis, they can interfere with nucleic acid synthesis, and they can interfere with the protein synthesis. In inhibition of cell wall synthesis, this include the beta-lactam, which broadly broken down into penicillin, cephalosporin, carbapenems, monobactams. It includes also in this category the vancomycin, daptomycin, and the polypeptides. In the inhibition of protein synthesis, in 30S subunit, it includes the aminoglycosides and tetracycline, while in 50S ribosomal subunit includes the macrolides, clindamycin, linezolid, and streptogamins, also the chloramphenicol. In the inhibition of nucleic acid synthesis, which are the DNA and RNA, the DNA will be seen in the quinolones 4, and the RNA includes the sulforamides and trimethoprim.
Characteristics of an ideal antimicrobial agent. First is must demonstrate selective toxicity for the disease agent. When we say selective toxicity, meaning that it selectively kills or inhibits the growth of microbial targets while causing minimal or no harm to the host, regardless of site of infection, without affecting beneficial gut microbes or causing undue toxicity to the host. Second is cause no allergic reaction in the host. An ideal antimicrobic is non-allergenic. Third is stable when stored in solid and liquid form. It is stable whenever it is in solid and liquid form. Fourth is reach the site of infection. When you swallow all antibiotic pill or liquid, it enters your digestive tract and it is absorbed into the bloodstream just as nutrients are from food. It circulates throughout the body, soon reaching its target area where pathogenic bacteria are causing an infection. Fifth is remain in specific tissues in body long enough to be effective. The effectiveness of an antibiotic treatment is determined by many factors, mainly from three aspects: the antibiotic itself, the target pathogen, and the patient body system. 6 is kill the pathogenic before they mutate and become resistant enough. The main cause of antibiotic resistance is antibiotic use. When we use antibiotics, some bacteria die, but resistant bacteria can survive and even multiply. The overuse of antibiotics make resistant bacteria more common. The more we use antibiotics, the more changes bacteria have to become resistant to them. And the last is be available at reasonable cost. It means it is fair and not too high.
Mechanisms of drug resistance. The main mechanism of resistance are antibiotic describe essential structures or processes in bacteria. This in turn kills the bacteria or stops them from multiplying bacteria. In turn, involve many antibiotic resistance mechanisms to withstand the action of antibiotic. Second is limiting uptake of a drug, modification of a drug target, inactivation of a drug, and active efflux of a drug. These mechanisms may be native to microorganisms or acquired from other microorganisms. Example of bacteria that are resistant to antibiotics include methicillin resistance, Staphylococcus aureus, penicillin resistance, Enterococcus, and multidrug resistance, Mycobacterium tuberculosis, which is resistance due to the tuberculosis drugs isoniazid and rifampicin.